So we have a pulley and this object is here, and we have a like this, and we have like this kind of system we have. Okay, so this one is m1, this one is m2. So what will be relation between the acceleration of these two objects? So for now we are just going to find the relation between the velocity and acceleration. We will not write the equation of force. We will not write F equal to ma now. We will use these things later, but for now we are just going to relate the accelerations. Okay, so for that what we are going to do is, see, again we will do the same thing. So this length from a fixed position is suppose x1. From this fixed pulley the distance is what? x1, and from the same pulley this distance is suppose x2, and the upper distance we can say some constant c. Okay, so what we have done is, from the pulley the lower distance of mass m1 is x1, and from the same pulley the distance of mass m2 is x2, and from this position the upper end, this small length from here to here, is suppose c, some constant c. So what we can write is, we can write x1 total length. If we are writing the x1 plus x2 plus x2 twice, x2 will be twice, x2 this side and x2 this side, so 2x2 plus constant c, that is going to be equal to length. Okay, so x1 this side, then x2 twice, then c. So this is the total length of the string. Now if you differentiate it, then all the constant things are going to vanish. So length is constant, this is constant, c is what? From here to here distance, that is not going to change. So this will become v1 plus 2v2 equal to 0, or we differentiate it again. That will be 0, so we can write a1 plus 2a2 equal to 0, or we can say a1 is double of a2 with negative sign. So what does it mean? Okay, so a1 is double of a2. So if this object is suppose going up with acceleration a, if a2 means what? The a2 means what? Rate of change of this x2, double differentiation of this x2. So acceleration of pulley or acceleration of m2, the double differentiation of x2, what is going to give? It is going to give the acceleration of m2. So if m2 acceleration is a, then m1 acceleration will be just in opposite direction with 2a. Why double? Because we have got double. And why opposite? Because we have got minus. If this object is going up, this second object is going down. Okay, so in this way we can find the acceleration between the two objects. Okay, we will take some more examples. Suppose next example we take. Okay, this kind of system we have, and we have pulley here, 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 and here. Okay, so we have system like this. Okay, this is suppose m1, and this is suppose m2, another mass. Okay, we have to find relation between the acceleration of these two objects. Okay, so what we will do is, we will write this length, suppose here to here, we will write, suppose this is x1, and from here to here we will write x2. From here to here we will write x2. So x1 is this side and x2 is this side. And now the upper length, this constant c, that we do not need to write, because we can see that c is going to get after differentiation, that is going to vanish. So no need to write these constant things again and again. So what we will do is now we will write total length. So total length, length L will be equal to, length L of the string will be equal to x1 once, twice, x1 once, twice, thrice, 4 times, 5 times, 6 times, 7 times, 8 times, up to 8 times. So x1 is 1, 2, 3, 4, 5, 6, 7, 8 times. 8 times x1. And then x2 from here to here. So x2. So this is the relation we have got. Now if you differentiate it, you will have 8 dx1 by dt plus dx2 by dt. So if you write, that is 0 equal to 8 v1 plus v2. So what we can see is v2 is minus 8 v1, or if you differentiate further, a2, the acceleration is minus 8 a1. So how the accelerations are related? So acceleration of 2 is 8 times. So 2 is this one. So this acceleration is 8 times of this one. So if this object goes up with acceleration a, then this will come down with acceleration 8a. Okay. So in this way we have to apply the constraint relation.